Hello everyone. This video gives you a detailed description of a three-phase series compensated network which is used for transmission. Basically, it consists of a three-phase 60 Hz 735 kilovolt power system transmitting power from a power plant consisting of a 6 350 MVA generators to an equivalent network through a 600 km transmission line. The transmission line is split in two 300 km lines connected between buses B1, B2 and B3. Now a small demonstration how this model works. Notice that the system contains the power GUI block. In addition, when you start the system, the sampling time is set at 50 e to the power minus 6, which is automatically set in your workspace. The system is therefore be discretized using a 50 microsecond sample time. In order to check the line to ground fault, double-click the data acquisition block and open the three scopes. Start the simulation. As the system has already been initialized at 1500 megawatt generation at the 13.8 kilovolt bus with the load flow utility of the power GUI, the simulation starts in the steady state. At t equals to 1 second cycle, a line to ground fault is applied and the fault current reaches to 10 kiloamperes. During the fault, the MOV conducts at every half cycle and the energy dissipated in the MOVB builds up to 13 mJ. Now there is a fault breaker between the bus bar 1 and the bus bar 2 at the first 300 kilometers of the system, and new readings are recorded, which can be seen with the help of data acquisition block. As faults have already occurred in the system, in order to compensate the system, we install a series compensator which helps the system to withstand at the time of when there is a sudden increase in the current. As power is equals to V1 into V2 upon XL into sin del, where XL is inversely proportional to the power. At this time, the XL should be minimum in order to give the maximum power. New results can be recorded with the help of power GUI and the data acquisition block after the series compensator has been added to the system. In order to increase the transmission capacity, each line is series compensated by capacitors representing 40% of the line reactance. Both lines are also shunt compensated by a 330 MVAR shunt reactance. These shunt and series compensation equipments are located at the B2 substation, where a 300 millivolt ampere 735/230 kilovolt transformer with a 25 kilovolt tertiary winding feeds a 230 kilovolt 250 megawatt load. The series compensation subsystems are identical for the two lines. For each line, each phase of the series compensation module contains the series capacitor, a metal oxide varistor MOV, protecting the capacitor, and a parallel gap protecting the MOV. When the energy dissipated in the MOV exceeds a threshold level of the 30 mJ, the gap simulated by the circuit breaker is fired. CB1 and CB2 are the two-line circuit breakers. By applying the parallel compensators and the series compensator, we can reduce the losses of the transmission lines, and we can increase the efficiency of the power system and the power transmission lines. In overall, we are increasing the efficiency of the transmission lines with the help of series compensators.